Hello everyone, Atoms Part 2, Bohr's model of hydrogen atom. Before seeing the Bohr's model, we can see what were the limitations of Rutherford's atomic model. First is that the model was unable to explain the stability of atom. That is, according to classical electromagnetic theory, an electron when accelerated will emit electromagnetic radiation in the form of electromagnetic waves. Hence, an electron moving in a circular orbit, which is accelerated by the Coulomb's force, which is centripetal in nature, will gradually lose its energy and ultimately fall into the nucleus. Then the second reason is this model was unable to explain the line spectra observed. That is, as the electrons spiral inwards, their angular velocities and hence their frequencies would change continuously, and so will the frequency of light emitted. Thus, they would emit a continuous spectrum in contradiction to the line spectrum actually observed. So, in order to overcome these limitations, Bohr proposed an atomic model. That is, Niels Bohr made some modification to the Rutherford's model by adding the ideas of quantum theory. Bohr in 1913 concluded that electromagnetic theory could not be applied to the processes at the atomic scale. It meant a radical departure from the established principles of classical mechanics and electromagnetism to understand the structure of atoms and the relation of atomic structure to atomic spectrum. Bohr was able to combine the classical and early quantum concepts, and he gave a theory in the form of three postulates. Now we can see the three postulates. Postulates of Bohr. First is, in an atom, electrons could revolve in stable orbits without emitting radiant energy. He also stated that each atom can exist in certain stable states. Also, each state has a definite total energy. These are known as the stationary states of the atom. Now, the second postulate. In the second postulate, he defined these stable orbits. That is, this postulate states that the electron revolves around the nucleus only in those orbits for which the angular momentum is some integral multiple of h by 2 pi, where h is the Planck's constant, which is equal to 6.6 into 10 raised to negative 34 joule second. Thus, the angular momentum of the orbiting electron is quantized. That is, L is equal to n into h by 2 pi. Now, in the third postulate, Bohr incorporated early quantum concepts into the atomic theory. According to this postulate, an electron can transition from non-radiating orbit to another of a lower energy level. In doing so, a photon is emitted whose energy is equal to the energy difference between the two states. Hence, the frequency of the emitted photon is given by h nu, where nu is the frequency and h is the Planck's constant, is equal to Ei minus Ef, where Ei is the initial energy level and Ef is the final energy level, and Ei is greater than Ef. Now we can see some relations from Bohr's model for hydrogen atom. Now, angular momentum L is equal to the product of mass, velocity, and the radius. But according to Bohr's second postulate, Ln, which is the angular momentum for an n orbit, is equal to mvn Rn, which is equal to n into h by 2 pi. But we know that Vn, which is the velocity of the electron in the orbit, is equal to E by root of 4 pi epsilon 0 m Rn. where E is the charge of the electron and epsilon 0 is the end of permittivity of space. Now combining these equations, we get Vn, which is the velocity of the electron in the n orbital, is equal to 1 by n into E square by 4 pi epsilon 0 into 1 by h by 2 pi. Similarly, the radius of the n orbital is equal to n square by m into h by 2 pi the whole square into 4 pi epsilon 0 by E square. Now the total energy for an electron in a hydrogen atom, En is equal to negative me raised to 4 by 8n square epsilon 0 square h square. On substituting the values of these constants, we get it as 2.8 into 10 raised to negative 18 by n square joules, or it is equal to negative 13.6 by n square electron volt. Now we can see the concept of energy levels in the case of hydrogen atom. The energy is least for an atom when an electron is revolving in an orbit closest to the nucleus. The energy progressively increases for outer orbits. Now the state of atom wherein the electron is revolving in the orbit of smaller Bohr radius is known as the ground state. In this state, the atom has the lowest energy. The energy in this state is E1 is equal to negative 13.6 electron volt. Hence, the minimum energy required to free an electron from the ground state of an atom is 13.6 electron volt. This energy is the ionization energy of the hydrogen atom. This value agrees with the experimental value of ionization energy also. At room temperature, most of the hydrogen atoms are in ground state. When a hydrogen atom receives energy by processes such as electron collisions, that is, if we heat the hydrogen, the atom may acquire sufficient energy to raise the electron to higher energy states. The atom is then said to be in an excited state. Now this figure shows the total energy levels for each level in the case of hydrogen. That is, for n is equal to 1, which is the ground state, it is negative 13.6. It goes on increasing as small letter n increases. In excited state, n is equal to 2, it is negative 3.40 electron volt, and for n is equal to 3, it is negative 1.51 electron volt. Now the energy required by the atom to excite an electron to the first excited state, that is n is equal to 2. E2 minus E1 is equal to 10.2 electron volt. Similarly, to n is equal to 3, it is given by 12.09 electron volt. Now from these excited states, the electron can then fall back to a state of lower energy, emitting a photon in the process. Thus, as the excitation of hydrogen atom increases, that is, as n increases, the value of minimum energy required to free the electron from the excited atom decreases. So this is the end of this video. In this video, I have discussed about the Bohr model of atom. If you have got any doubt, please comment in the section below. Thank you.